It's starting to become clear. Will we just skip summer and move directly into winter? I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Monday, August 7th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. And if for some reason the video is delayed, we can also reach you to let you know when the new video will be posted. And you can subscribe by clicking the little Stormsurf icon down in the lower right-hand corner of your screen. Just click that and get signed up, and then you get the notifications. If you'd like to donate it to the cause, just hit the special thanks button, the heart with the $sign in it. You can send us a tip, $1 or $2. We appreciate it. And with that, I'd like to thank the folks that donated last week. Big B, Jason Modem, Sam C, Spat Out Glory Film, Ramil Sandikov, Victor Mackay, Osprey Files, and Francis Tuckermans. Thank you all very much for your contribution. And with that, let's get to work. First up, looking at significant wave heights for the South Pacific Ocean. Again, we have this just placid pattern, a little bit of some wind blowing in the Southeast Pacific, east of the Southern California swell window. San Diego, about 117 west. Any system that's east of that line pretty much won't push any swell up to Southern California, much less Northern California, unless it's really at some bizarre southeast angle, which doesn't happen very often. And the area under New Zealand, for the moment, pretty quiet, so no swell production is occurring at the moment. We'll start by looking at current conditions along the California coast. Start in Northern California, really Southern California, but close enough. San Francisco Bay Area. Point Reyes, California, 029, buoy number 029. That's a CDIP buoy. We're looking at all the energy hitting that buoy at this one particular reading. It updates every half hour. 33.3 second period energy is super long period energy, which we have none. You see little bits of energy, 0.2 of a foot at 25 seconds. A little bit more energy, 1 foot at 15.4 seconds, then a whole bunch of energy down here in the 2 to 3 foot range in about the 7 second period area. 5 seconds is pure wind chop. So this is wind swell. This is some ground swell from somewhere. We'll get into that in a minute. And this is maybe some newer ground swell. Using our specialized math to sort out pure swell size. Primary swell, 7.1 feet at 6.7 seconds from 319 degrees. That'd be surf height at about 4.7 feet. That's probably a little bit on the high side. Then you see some secondary swell, 1.4 feet at 15.5 seconds from 225 degrees, 2.2 foot surf. Trying to tease out the source of that longer period energy, we're going to take a look down at Point Santa Cruz buoy number 254, another CDIP buoy. We see most of the wind swell not hitting there because it's shadowed and south facing, but we see that bump of energy in the 14-15 second period range. Primary swell, well, wind swell still beat it. 2.8 feet at 7.4 seconds. That's 2 foot surf. With the secondary swell, 0.9 feet at 15.7 seconds from 190 degrees. A foot and a half. And yeah, the surf is, I don't know, knee to waist high, something like that on the sets if you're patient. Heading down to Southern California, the southmost, most exposed buoy along the coast, the Point Loma South buoy, number 191. Again, we see this bump of energy, a little bit bigger here in the 14-15 second period range. A little bit of dribble out there at 18 seconds, and the wind swell not nearly as prominent, shadowed by the Channel Islands. Primary swell 1.6 at 14.6 seconds from 171 degrees. Well, it's more like 190. And that puts surf at about 2.3 feet. Yeah, there's some chest, shoulder high surf, maybe even a little bit bigger at select locations. And then the bits of the wind swell sneaking through the Channel Islands, 1.7 feet at 10.4 seconds or a foot and a half. And then we go to the south shore of Hawaii, Barber's Point. This is on Oahu, buoy number 238. We see, again, this little bit of energy out around 18 seconds, some more energy in the 13, 14 second range, all the way down into pure wind chop. Put it all together, primary swell, okay, I guess the wind swell wins. 2.2 feet at 9.7 seconds from 163 degrees. That's surf at 2 foot. And then that secondary swell, 1.4 feet at 12.8 seconds from 174 degrees, again in the 2 foot range. And it's waist high or something like that on the south shore, maybe even a little bit bigger at times, and rideable. And though we're not going into the details because there's nothing going on, yay, the Waimea Bay buoy on the north shore of Oahu is finally back up and running, so that's perfect timing for the fall season. All right, so where's the swell coming from that is not wind swell? We know there's some sort of longer period energy coming into Hawaii. There's also some longer period energy coming into California. Small, be it, it's still better than nothing. So back Monday on July 31st, little gale developed south of Tasmania here. Well, really a storm with seas up to 44.8 feet. These are the highest seas here over the entire domain. Producing swell that tweaked or pushed its way up through Fiji, through the channel here, hit Hawaii, and bits and pieces of that are hitting California, but it's very small, very inconsistent, and pretty weak. That system faded out, but then let's go right about here. You can't even go what are you looking at? Well, right here on Wednesday, August 2nd, a little gale, remnants of that system, tried to develop near just off east of the southern tip of New Zealand. Seas built to 28 feet. Right there's Chatham Island, unobscured, and then pushed north again at 28, almost 29 feet, aim north, and then continued into Thursday. A secondary fetch of energy tried to get going, maybe producing 25, 26-foot seas aim north. Now, the nice thing about this is it's super west angle, which southwest facing spots that love that kind of angle. This is like a 220-degree swell relative to California, and it's well clear of any shadow relative to Hawaii being at 158, roughly up here off the top of the chart. So small southern hemi swell is tracking towards the Hawaiian Islands. Maybe the first little stray pieces of it are trying to show at the buoys there, and also towards California. Now, the operative word here is it's going to be small. You saw how tiny the fetch area is here, so don't expect anything big. It's like longboard surf at best, but hey, it's something to ride. Beggars cannot be choosy. Then we went into this past weekend. We're just looking for anything that might have happened. Another little system tried to organize just east of Chatham Island, but not even close to big enough. And let's see, we're right about here we are now today, and really nothing since then. All right, so what's to come for the future? We're going to start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough that is a push in the jet to the north in the southern branch of the jet. I mean, if ever you would want to see the north and the southern branches of the southern hemi jet, this is it. The northern branch right here dominating with 140 knot winds running pretty much flat west to east on about the 27 south latitude line, pushing into Peru and Chile. The southern branch way down, so you can't, New Zealand there, Australia there, Chile there. The ice line, though, you can't see it here. It's about 64 south, something like that. So this is the southern branch all over Antarctic ice and completely buried, offering no support for gale development. What we're looking for is a trough, a push in the jet to the north and then falling south. That helps create a clockwise flow aloft in the upper atmosphere. That's the hallmark of low pressure in the southern hemisphere. That low pressure upper atmosphere pattern also manifests itself down at the surface. Of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on ice-free waters of the ocean surface and generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell. swell when hit reach turns into surf. So we have no troughs, we have nothing, and so we have this massively split jet. All that does is create high pressure in between, and high pressure generally doesn't produce enough wind in and of itself to generate meaningful seas other than maybe 6 or 7 period wind chop, and that's about it. So really no hope from the models as of right now. Just looking forward, you're going to see this pattern continue. Now notice as we get into Wednesday, and typically we don't look at this branch of the jet for offering troughs or support for gale development. You see this wavy dipping thing here? Well, you can get that clockwise eddy flow right there, and maybe that'll provide some support. Look at this, even as we get into Thursday, 180 knot winds pushing up into this trough. So that possibly, and you just typically don't see them this far to the north at like 35 south. You look down, you hear about the roaring 40s in the southern hemisphere. Well, it's really more like the roaring 50s and 60s. But to get anything in as desperate as we are, maybe there's some potential here Thursday into Friday the 11th of August. So we'll keep our eyes on that. Now we get into Saturday and Sunday. It's still, look at this, they call it a zonal pattern when the jets just split like this and running parallel at each other. Just continues on unchanged for the next week. This is kind of where in the title we were talking about, is summer really over? And then we're going to show you a little bit something later on. You're probably just going, you're out of your mind. What are you talking about? We're going to show you something later on that might give you a pause for a moment. But let's move on. All right, surface level pressure, surface level winds. We know based on the jet that there's literally no support for gale development. That said, there's this little thing with 35 knot winds. Forecast on Tuesday, August 8th off of Chile, but again, out of our forecast area. But then as we get into Wednesday, remember that strange little trough we saw in the northern branch of the jet? Well, look at this. Some sort of a low is forecast developing from that with 35 to 40 knot south winds, 45 knot south winds, and that's spraying anywhere from Hawaii up into California and, of course, into Mexico, Central America, and maybe down even into Peru. Continuing into Thursday with additional 40 knot winds pushing up from the south. This is on the 10th of August, and then fading out from there. Now, another system is forecast off of New Zealand. You go, hey, that looks great, but notice it's falling south, and most of the fetch in it is over in its eastern quadrant falling south. Winds circulate around low pressure in a clockwise manner, right? So all that fetch aimed at Antarctica. You need the fetch over in this quadrant of the storm aimed up towards Hawaii and California because that's our primary forecast region. And the low itself has to be traveling north or northeast towards you. And watch this system, just plunging to the southeast. So we've written that off completely. And now we're into Sunday, almost a week from now, 13th of August. And we're into the 14th of August. And we're 180 hours out and nada, nothing. Where is our summer? All right, so what's the effect of those winds on the ocean surface? You got to have winds to make seas and seas to make swell. So we're looking for seas of 24, 25 feet or better, and I'm really like reaching the bottom of the barrel. Normally my standard position is if there aren't 35-foot seas in the southern hemi aimed at us, I don't even want to hear about it, but I'm as desperate as the rest of y'all, and I'll grovel. So the good news is, on Wednesday evening, the 9th of August, we have, what do we got? 20, 22, 24, 25-foot seas forecast aimed north. That's 54 hours out. That's probably close enough to maybe start believing the GFS model. Building to 26, almost 28 feet. Okay, the highest waves or sea heights 30 feet, but that's down here, not in our swell window. So this guy is the main potential for swell production, with seas in the 25-foot range continuing into Thursday and then fading from there. The good news is it's pretty far to the north. That shortens the travel distance to Hawaii and to California, and it's relatively reasonably close on the model. So hey, perhaps maybe another bout of swell could be showing up. All right, so we push on out. We're into Friday. Now, here's our next system. I'll pull this away here for a second. You can see it off of New Zealand. You see the 28-foot seas, but it's all falling south, and you watch this, the whole thing just crashing south. So no hope there. We're out to Monday, the 14th of August. Oops, and literally nothing. So one more on the charts giving us some hope. Next up, local wind swell. So those of you that have been watching, we've been just this nonstop, like winterish type pattern with the north winds. It's actually like a spring pattern. North winds nuking along the California coast, creating upwelling, creating cooler than normal conditions water-wise, stronger than normal trades on the Hawaiian Islands. Right here, here's the poster child for the pattern we've had all summer. 20 to 25 knot north winds along the North California coast. But notice it's been the focus of this gradient where the strongest winds are. Normally in the summer they're from San Francisco northward. This whole year they've been down off of central California. We're starting to see signs that this is lifting off to the north. Clearly there's a tropical system developing. It's not much of a system. We'll get into that in a minute. There's another one. In fact, maybe here we can drag it down here. You can see it. Stronger system, hurricane southeast of Hawaii. We'll get into that in a minute too. Anyway, we're looking at the potential for local wind swell. Yes, for California, northwest winds 25 knots off the North California coast, generating local wind swell. Trades 20 knots pushing into the Hawaiian Islands, doing the same thing. So we get into Tuesday, the gradient starts fading in California. Still some wind swell, but not nearly as large an area. The focus of the high pressure system building, that due to, here we go, there's the tropical system, high pressure to the north. The difference in pressure between the deep low and the strong high tightens up the isobars. Look at these little blue lines all stacked here, creating increased trade. So you see that relative to Hawaii. That system, we'll see if we can get the date here. Yeah, by Tuesday evening, it starts passing south of the Hawaiian Islands. We're into Wednesday morning, are we here? Yeah, here we are, Wednesday morning. Notice high pressure off here. No gradient along California. The northwest winds, 10 knots over open waters, not bad at all. Trade's still blowing pretty good for the Hawaiian Islands at 20 knots, but we know as the tropical system moves east, that will all fade out, and you see it as we get into Thursday there. Light wind regime for the California coast. As we get into Friday, though, well, you should be looking here, but I'm looking out here and going, what is this? And it's the beginning of August. Normally, starting about August 15th, I start looking up here to see what's going on. So just bookmark that for a minute. We'll get into the details in a bit. But local wind swell, no wind swell for California. That's a good thing. Ocean waters potentially warming up because there's less turbulence. Trades slackening for the Hawaiian Islands, at least for a day. Saturday, same deal for California, same deal for Hawaii. Big low pressure in the Gulf of Alaska. So we get into Sunday. Trades come back 20 to 25 knots, limited to the Cape Mendocino area, and from about Point Arena southward, a relatively light wind regime of no real consequence. Light trades for the Hawaiian Islands. And as we get into Monday, more of the same with the gradient pushing further to the north for the first time. This looks like a normal summertime pattern. Maybe we have turned the corner. All right, tropics. So there is a tropical depression, Eugene, with winds 30 knots right here. You can't see that's Guadalupe Island. Baja California's off here. Traveling off to the northwest as we get into tomorrow. That would be what? Tuesday the 18th. Winds down to 20 knots, sort of recurving around, but 20 knot winds are nothing. I mean, maybe that's good for some tiny wind swell that'll work its way up into Southern California, but for the most part, I'm not really paying attention. But there is a more significant system. We saw that before. Southeast of Hilo, Hawaii, the Big Island. Winds 115 knots. I think that's about 135 mile-an-hour winds. And you see it on this westerly track continuing out for, what's that, another 5 days or so. Still at hurricane strength, 70-knot winds. Now, no direct swell for this is forecast for the Hawaiian Islands other than the south shore of the Big Island. And I think that swell starts tonight into tomorrow. Tomorrow will probably be the biggest. And But again, southeast shore only. Don't think any of it's going to be, it's all going to be pretty much shadowed up here. Maybe there'll be some little dribbles, sideband wind swell into Maui and Oahu, but I'm not really counting on it. But there is a tropical system and it's pretty solid. And we'll be watching this long term to see if it recurves off to the northeast. Typically, we don't expect to see something like that until about August 15th. But if we do, then that would speak very much about the North Pacific jet stream. And then looking into the high Sierra, if you're a backpacker trekking up on the John Muir Trail or somewhere in the high Sierra, temperature forecast, we're at the intersection of Tioga Pass Road in Yosemite and the Pacific Crest Trail. Right at that spot where they intersect, the elevation's about 8,700 feet right here. So let me see if I can pull this up a little bit more. Okay, so these are dates across the bottom. This is elevation. These are temperatures. So if you're at 8,700 feet, you can just eyeball across here for the next 10 days and go, the temperatures are 50 to 60 degrees and maybe touching 70 degrees. Now, if you get higher up, let's say you're hiking, you're up at 10,000 feet, well, then temperatures are 50, basically 50 and 40s at night. I was just up there a day ago, and that's about what it is. Up high, temperatures cool, not cold, but coolish in the evenings, warmer during the day, mosquitoes in full bloom anywhere above 9,300 feet. Still snow, still rivers flowing like mad, a lot of snow melt going on, very boggy, muddy if you're anywhere near the snow, perfect breeding ground for mosquitoes. So if you're going, prepare yourself. It is a feeding fest and you are the feast. All right, so what's all this mean in terms of surf? Well, we'll start in Northern California. For the most part, basically just wind swell. These are surf heights, 4 feet down to nothing and 2.5 feet, something like that. Looking at the swell heights, 5 feet, and the period 7 seconds, pure wind swell, dropping down to nothing, and then again more 2 to 3 foot wind swell in the 8 to 9 second period range. So nothing too special. Going to Santa Cruz, and this goes out about the next week, continue the same sort of deal. Now, this forecast location is sort of off the coast of Santa Cruz. It's not like right tucked in there on, the east side Capitol or something like that. So it's mainly the whole wind swell drill again, 3 feet, 2 foot surf, that sort of thing. Looking at swell heights, swell heights, 3 feet fading down to 2 feet into Thursday and Friday, and 2 feet at 10 seconds for the weekend into Sunday. That said, there is something hidden underneath all that. Well, let's go down in Southern California. We'll do the Dana Point forecast. Okay, surf heights again, still like 2 feet, nothing special. But if you start digging in here, you can see swell heights 1.5 to 1.8 feet in the 12-11 second range. That could be some tropical. It's a mixture of tropical swell. And there's also today where there was the last little lingering bits of swell that came through the Tasman Sea, the Tasman Channel there with Fiji. But that's pretty much all gone. But maybe some background swell, 1.5 feet at 12 or 13 seconds of tropical origin. Now that said, even this doesn't show it very well. But as you get into Saturday and Sunday, that new swell, that tiny swell, that system that was right there on the east side of New Zealand, somewhere, and this is true for both North and Southern California, some of that swell should be starting to arrive with surf heights. Well, you saw it, 1.8 feet, something like that. But you can see bits and pieces, 1.2 feet at 14 to 15 seconds. And even in Saturday, this isn't even teasing it out because it's like the third swell in the line. But, 1.5 foot at 15 or 16 seconds. So maybe something to ride, but given the tiny fetch size and the long travel distance, it'll probably be 1 or 2 waves every 20 minutes if you're lucky. Then we go to the south shore of Oahu. We see surf heights pushing up into Tuesday evening, early Wednesday morning. This is wind swell generated from Dora south, pushing south of Oahu. So maybe, I'm sure this is a bit overstated here, but potential for some wind swell. And then down to pretty much nothing. You can see it here. Swell heights 4 to 5 feet at 12 seconds. I don't know that I'm really buying it. For the South Shore, or for the Southeast Shore, the Big Island for sure, and probably much bigger than this, but for Oahu, well, we'll go with it and say it's there. And then you see the New Zealand swell also hitting starting Thursday, 2 feet at 14 seconds, dribbling down as you get through the weekend, but providing, well, let's see here, 2 to 2.5 foot surf and then fading from that. So some surf for the weekend and the later part of the work week for the South Shore of Oahu. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and, of course, the El Nino Southern Oscillation. These two oscillations are the main factors in terms of swell and weather for the Pacific Basin, especially during winter months. All right, we're going to start by looking at the Madden-Julian Oscillation. It is this periodic weather oscillation that travels from west to east on the equator around the planet. The active phase on one side of the planet, the inactive phase on the other, they rotate west to east. The active phase is like a low pressure system, the inactive phase like a high pressure system. The active phase, being a low pressure system, takes warm moist air down at the ocean surface, lifts it high up into the atmosphere. That gets caught by the jet stream. It feeds energy to the jet stream. A stronger jet stream produces troughs. Troughs produce gales and storms, which results in surf, and in winter months, rain and snow into California. So the active phase is very much what we're interested in. Also, when the active phase of the MJO is in the far west Pacific, it dampens trade winds. And when the trade winds are dampened, that allows warm water pulled up in the far west Pacific to start sloshing east underneath the equator in what's known as a Kelvin wave, a ball of warm water that takes about 4 months to make it from the far west Pacific, just off the maritime continent. Erupting event travels under the ocean surface, eventually slamming into Ecuador, erupting to the surface and creating a pool of warm water there. If you have successive active phases of the MJO, they create successive Kelvin waves, and that warmth being transported to the East Pacific is what helps to usher in El Nino. The warm water in the East Pacific there then starts evaporating to the surface. It eventually starts changing the atmosphere above it, creating lower pressure in that area, and then a thing known as the Walker circulation starts changing. We talked about this last week. There's a whole tutorial on it, so I'm not going to go into it tonight. But when the Walker circulation changes, that's typically in response to a developing El Nino, and that really brings the center of energy and moisture and rising moist air high up into the atmosphere. It brings it into the Dateline region and even much further east than that, and then that really sets up El Nino, which peaks typically in the November time frame, and it makes all sorts of havoc, but also rain, but also lots of surf, depending on how east-based the El Nino is and how strong the El Nino is. And then, of course, if you have multiple inactive phases of the MJO, then you get what we've been suffering through for the past 3+ years, which is La Nina, high pressure, no energy transport into the jet stream, and generally boring conditions. All right, so we're going to start by looking at data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. This is the East Pacific here. This is the West Pacific here. 0, that's the equator. That's New Guinea right there. The date line is right there. We're just looking at the arrows. These arrows are 5-day average wind speeds. They are measured by the buoys. The longer the arrow and the direction tells you if the wind is strong and what direction it's from. So strong trades out of the east and the East Pacific, pretty normal. Moderate trades over the Central Pacific, weaker than what they've been. And then in the far, starting about 175 east, trades pretty much just die to nothing, which is a bit unusual. It smells very much like the active phase of the MJO. Now, it's not the actual wind speeds that really matter. It's the anomalies, the difference from normal for this time of year. So trades a little bit stronger from the east in the East Pacific, but whoa, what's going on here? We actually have westerly anomalies in the central Pacific. Not strong, modest, but we have them, and they are also over the Kelvin wave generation area, the far west Pacific. This is very good news. So what's been going on the past 5 days? 850 millibar vector wind anomalies. Just the east-west component of the wind. Are the winds blowing more out of the west or more out of the east? The oranges are westerly anomalies, synonymous with the active phase of the MJO. The blues, easterly anomalies, the inactive phase of the MJO. But all we care about is the far west Pacific. So here is South America, Central America, Hawaii, New Guinea, the equator right there, dateline right there. It is this area from 5 degrees north and south of the equator, from 175 west to as far in the west Pacific as you can get. It's about 125 east, right there. Put a box right there, and I call it the Kelvin wave generation area. When you get westerly anomalies just like this, like we had on the 1st of August, the 2nd of August, the 3rd of August, the 4th of August, the 5th of August, and then moving, notice, also building over the central Pacific, and notice these easterly anomalies in the far east Pacific getting, well, trying to get weaker. It seems like a wall of westerly winds are pushing that way. This certainly smells of the active phase of the MJO for the past 5 days has been over the Kelvin wave generation area, potentially building a Kelvin wave, and that is very good news. Here is a different depiction of the zonal wind anomalies, 850 millibar zonal wind anomalies. So that's up about 4,700 feet. That's not down at the surface, but it's a pretty good proxy for what's going on at the surface. And it sort of gives you a sense of what the active and inactive phase of the MJO is doing. All right. Reds and yellows, westerly anomalies, typically attributable to the active phase of the MJO. Blues, easterly anomalies, the inactive phase, more or less. And you go, well, it just looks like a bunch of mess on here. It kind of does. But let's put some parameters around this. Far west Pacific starts at 125 east right here. And the Kelvin wave generation area ends about 170 west right here. And why? So this is what's been happening. Notice the dates here. This is the forecast for what's coming. And what really jumps out here, and we've been watching this back in July. We were like, July 13th is the day. It's all going to change. You know, that's when El Nino starts. And it kind of came, and we saw this pattern. And yes, there are westerly anomalies, and it kind of looked okay. It started actually on the, I'll say the 15th. Okay. But it just keeps going and going and going. So it's been 3 weeks, and that's typically about as long as the active phase of the MJO lasts over one particular area. And you see this kind of pattern sort of slowly pushing off to the east. Looks like the active phase of the MJO has been in place, produced westerly winds, and we think possibly is contributing to the production of another Kelvin wave. Now you go, wait, we got blues here. That starts in 2 days. Well, the 9th, actually, it's 1 day. But it only goes for about a week. So a little pulse of easterly anomalies. And this is the GFS model. It said this was going to go on for weeks, you know. But now, lately, it's backed off and said, okay, a week of easterly anomalies. And then the westerly anomaly pattern starts up again. All right, so here's yet another depiction of this. This is, and let's get our, here's the equator. This is the Pacific Basin. You can barely see it here. Central America, Ecuador right there, the Galapagos there, equator running right there. Far east Pacific, there's New Guinea there. It actually, the West Pacific extends actually a little bit further than that. But the reds are westerly anomalies, the active phase of the MJO. The blues, easterly anomalies. So we're just going to plow through this thing. You see, here's our current situation. Westerly anomalies in the West Pacific, a little pocket of easterly anomalies just off the Galapagos, and then some westerly anomalies near Ecuador. So we put this in motion. We see the westerly anomaly pattern starting to fade, come about August 12th over here. And then watch it. It continues building through about the 14th, but notice the westerly anomalies building over here in the East Pacific. Now, this isn't good for Kelvin wave production, but what it suggests is there's been a lot of strong easterly anomalies here, and they've kind of been messing up the warm pool off of Ecuador and not helping it get really hot. We think that's going to quickly come to a close in, what's that, a week from now. And then notice that strong westerly anomalies in the East Pacific. And then right about as that gets going, over in the West Pacific, westerly anomalies start building the 18th of July. And then we get into the 20th, of August. And look at this. I mean, this is pretty impressive. Massive area of westerly anomalies by August 21st in the pretty much filling the Pacific Basin and continuing through the end of the model run. This looks like El Nino. And then one last chart here. This is, again, the 850 millibar zonal wind anomaly. Now, the nice thing here is you can actually see land masses. There is New Guinea, 125 each. That's where the West Pacific starts. You just drag that the whole way down the chart here. South America here, so the Galapagos here. But the Kelvin wave generation area starts right about down that line, goes to about 170 west. So this is the GFS model. You see the westerly anomalies. You see then come about August 11th or so, they start fading. You get that block of easterly anomalies. Now this only goes to the 16th. The model we saw before on the 18th, westerly anomalies start building. The GEFS model, pretty much showing the same thing, but westerly anomalies, well, if the Kelvin wave generation area ends right here, westerly anomalies continue or holding in the far West Pacific, making it almost to the date line by the 16th of August. That's only 9 days from now. The ECMWF model, the European model, says, yeah, you get that pocket of easterly anomalies that lasts for, we'll say, the 12th through about the 16th, 4 days. And then westerly anomalies start making a stand. So all in all, putting all the models together, it looks like, yeah, we're due for a little bit of easterly anomalies, but anywhere from 4 days to a week, we can live with that. And after that, it seems like we're off to the races. So if the active phase of the MJO is like a low pressure system, well, low pressure systems take warm, moist air, lift it aloft. They create clouds. All right. So this is a model of what you could call it clouds, outgoing long-wave radiation. Basically, sunlight reflecting off the ocean surface. If you have more clouds, you get negative outgoing long-wave radiation. That is, the sun hits the clouds, it makes it down to the ocean surface, but it can't bounce back. You get negative values. And let's get oriented here. There's the equator. There's South America, Central America, Hawaii, New Guinea there. Dateline right there. Kelvin wave generation area right there. We have yellows. That is positive anomalies. That means cloud-free skies. So this suggests inactive phase of the MJO for the next, well, today, 5 days from now, 10 days from now, 15 days from now, according to the statistic model. The dynamic model paints a little bit different picture. It suggests, yeah, inactive phase of the MJO. That's that, that east anomaly thing that we saw on the models. And it goes for 5 days, goes neutral 10 days out, 15 days from now, back in business. So the dynamic model and the statistic model on the last day of the image here show two different outcomes. We think the GFS, along with the ECMWF, probably, because that's in a dynamic model as well, probably have a better handle on the situation. And then we drill in looking at the phase diagrams for both those two models. Statistic model here, dynamic model here. How do you read this thing? Well, the MJO moves east to west on the equator around the planet. So from the Indian Ocean to the Maritime Continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. It's on the equator, nowhere else. Okay, the heavy dot is where the active phase is today. So this would be over Africa. These are the 1, 2, 3 different projections from the statistic model, basically putting it in the Indian Ocean. Now notice, if the dots are inside this circle, it's considered to be very weak. So a very weak active phase, only making it to the Indian Ocean. Now the dynamic model, the GEFS model, shows the MJO over Africa, but backtracking to the far West Pacific. Still very weak, but 2 weeks from now, it's set up in the West Pacific. And that's why this all makes sense compared with this here. Yep, both telling the same story, that the active MJO after a little bit of a break for maybe a week, is supposed to come back and start building. Not very strong, but we don't need very much. The upper level model, this shows propensity for precipitation. The greens, wet air. The reds and oranges, or the oranges and yellows, dry air. The greens, the active phase of the MJO. The oranges, the inactive phase of the MJO. This goes out 40 days. This is a statistic model. South America, Central America, New Guinea there, Equator there, dateline roughly there. This shows the active phase of the MJO over the West Pacific today, fading slowly into about August 22nd, and then gone, with the inactive phase only very weakly trying to show up in the West Pacific for maybe a week, and then a weak active phase trying to set up after that into, mid-September. So this is a dramatic improvement from what we saw the last video a week and a day ago, suggesting a more favorable pattern for the active phase of the MJO, which is exactly what we want for producing Kelvin waves and feeding energy to the jet stream. All right, so let's look out a little further. Let's look out a month. All right, same deal, east-west component of the wind, but this chart now has the black line representing the solid black contour, the active phase of the MJO, the dotted contour, the inactive phase of the MJO. Let's get ourselves oriented. Far West Pacific starts at 125 east, so roughly right there. Kelvin wave generation area ends at 170 west right there. This is past performance here. So you see a big active phase of the MJO with strong westerly anomalies, the reds, and tropical development that occurred in May. In June, we had a little bit of a westerly wind burst, a very weak active phase of the MJO. In the early part of July, the inactive phase of the MJO and easterly anomalies. And then starting about July 13th, boom, just solid westerly anomalies. There is only the faintest sign of the active phase of the MJO. Now, this is maybe going out on a limb, but typically during El Nino, the MJO pretty much disappears. And what happens is you get what appears to be a steady state active phase of the MJO. These lines don't show up anymore, but you see the evidence of it with just continual westerly anomalies. And that again speaks to the shift in the Walker circulation, with the center of the Walker circulation maybe on the date line, on the equator, or moving off to the east to a point south of Hawaii, or maybe eventually even into Ecuador, okay? But you see the westerly, this is the inflow from west to east into the Walker circulation and then up in the atmosphere. So we've been in this situation from July 13th, continual westerly anomalies. This model also suggests that little pocket of easterly anomalies a week from now, lasting a week, and then after that, it's off to the races. And this model really hasn't changed. I mean, a couple of weeks ago, we were going, is this falling apart? What's happening? El Nino has stalled. And it did, at least according to a bunch of the models. And the GFS model was the worst of them, just continually speaking easterly anomalies coming, doom and gloom. And they wouldn't come, and they wouldn't come, and they wouldn't come. And there would just be this insipid because it wasn't, barnstorming, but continual westerly anomaly pattern. This is stuff is in the bag. This is not a model projection. This is what's actually happened. So it suggests we've had this long-running westerly wind anomaly pattern in control now for 1, 2, 3 weeks, maybe going for another week. Maybe it'll stall for a little bit, but westerly anomalies still in the far West Pacific. And then they just start building from there. This is classic. If you want to see an El Nino build, this is exactly what you want to see. This is looking good. Again, I got to believe a model, which I don't really want to do, especially after kind of getting burned a little bit over the past couple of weeks. But in the end, the doom and gloom the GFS was saying hasn't materialized, and the CFS has had a much better handle on this than one could have possibly imagined. That is good news. All right, so if I can't go out a month, and I have problems believing that. Why would I go out 3 months? Well, because I like to tease myself. All right, so this is data from the CFS model going out 3 months. Past performance is down here. The forecast is up here. Now, this is really weird. We've never shown this before. But this is outgoing long-wave radiation, cloud cover again, right? Okay, past performance is down here. So back in Kelvin wave generation area, 125 east to about 170 west, all right? The solid contour here is the low pressure bias. Think of that as the El Nino signal. Back in April and May, the El Nino signal was sort of in the West Pacific, but not, just barely, halfway over the maritime continent, halfway in the West Pacific. And the high pressure bias here, the dotted contour, the La Nina signal, was over the date line. And we've continued that way. But then, and I just never looked at this model until just today. And then I look at June 28th, 29th, and all of a sudden the low pressure bias. Now, this is what's actually happened from this line below. Low pressure bias has set up smack over the date line, exactly as one would expect. The Walker circulation drawing up over the date line, taking warm moist air, pushing it up into the atmosphere. It was over here in the maritime continent, even back during La Nina, this low pressure bias was over here like a rock. Now this says Walker circulation is in place exactly where we want it to be. And even more so, the high pressure bias is now setting up over the maritime continent. So instead of this pattern, we are reversed now. And this has actually been going on since the end of June. Okay, and we've got a month or more on it already, which says this isn't just some phantom nonsense. Oh, and the blues here, increased building cloud cover, indicative of warm moist air being lifted aloft, hitting the cold air up above, falling out as rainfall, or at least making clouds. And then, of course, the forecast suggests this pattern only builds as we move forward. This is classic La Nina sort of setup. Now back to the more traditional view, the 850 millibar zonal wind anomalies. The yellows, again, Kelvin wave generation area right in here, okay? The past performance, here's the westerly anomalies that have been continuing. Again, another indicator of the building of El Nino, and forecast just to continue building solid for the foreseeable future. I would be interested to see more of the blues over in this area, but whatever, I'll take this right the way it is. Let's overlay the MJO. All right, so active phase of the MJO in control right now. Inactive phase moving into the Kelvin wave generation area as we speak. It's supposed to last for a week and a half, and westerly anomalies to persist. There's that pocket of easterly anomalies, so that's associated with a very weak inactive phase of the MJO. And then after that, a very weak MJO pattern, but look at this pretty solid westerly anomalies the whole way through into at least November. Let's overlay the low pass filter, the low pressure, high pressure bias thing, the clear El Nino low pressure bias moving from April in the maritime continent over the date line today with 1, 2, 3 contour lines. Now, a couple of weeks ago, this third contour line wasn't there. It was broken in pieces every run of the model. The model couldn't get a handle on what's going on. Right now, it says, no, we're off to the races. 3 contours from now for the future. The high pressure bias, currently south of California. This is what is the last remnants of La Nina. This is what has been contributing to that ongoing north wind springtime conditions along the north and central and southern California coast, and the upwelling that steadily getting weaker and weaker and gone by October 18th. Every day I come and look and see, well, when's it supposed to be gone? And it's been locked solid right around October 18th for a couple of weeks now. So we're getting closer and closer to this, suggesting a real El Nino is underway and the stall is over. And then one last bit of information. Outgoing long wave radiation. This is the past here. Dateline running right up the middle. These reds and yellows suggesting very dry air, no rainfall. You can see it's been from, this was September, this was, August of last year. So a whole year. This is clear La Nina signal with all the blues, the clouds over the maritime continent. And then you got into May. It's sort of like just died. And then come the latter part of May, the wetter precipitation started showing up. Just one little reading, not too much. But then on June 23rd, and from then on, you get this unmistakable sign that clouds are building over the dateline. The Walker circulation is trying to get set up. And you also notice that the dry air is building over the maritime continent. Classic reverse. Wet air here over the maritime continent, dry air during La Nina. El Nino, wet air over the dateline, drier air over the maritime continent. A little bit late in developing for a super El Nino, and we're not saying that's where we're going, but it is developing. Next up, we're done with the MJO portion. Now we're into the El Nino, and we're looking, all this is about now looking for evidence that the ocean and the atmosphere are coupled, or that the fuel is in place to support the development of an El Nino. So we start with the TAO buoy array, that series of buoys strung across the equator used for monitoring El Nino. Okay, perfect time to be using it, right? Looking at these little X's here, these are the anchor lines on the buoys. The X's are individual sensors. The sensors, married with a model to fill in the gaps here, give you a profile of the warm water, cold water balance in the Pacific Ocean, just on the equator, 2 degrees north and south of the equator, West Pacific here, East Pacific here. This is temperatures in centigrade. So 30 degrees centigrade temperatures from extending on the surface from the far West Pacific to the dateline and a little bit beyond to maybe 178, maybe 177 west. This is about where it was last week. 29 degree isotherm. It was at 161 last week. It's at 159. So evidence of, very limited evidence of warm water trying to push east. 28 degree isotherm. It's exactly where it was last week. No change. The 24 degree isotherm. Here's a little scary bit apart. This was down at 65 meters deep. And then last week it was right at 50 or maybe 45, and now it looks like it's about 35 meters deep, suggesting that warm water here, not as deep as it was, a thinning of the warm pool here. But let's go, rather than look at the actual means, let's look at the anomalies, the difference from normal for this time of year. So we see the warm pool here, West Pacific here, East Pacific here, and Kelvin waves travel west-east down to about 150 meters deep, so draw a line right there. We see the warm pool with 2, 3, 4, 5, it was up to 7 degrees above normal temperatures, but still a very healthy supply of warm water here in the East Pacific. And what's that mean? Well, we've had 5 Kelvin waves produced between December and May or June, something like that, and they've taken 4 months to move across, but they all sort of backed up into each other and just created this massive warm pool of warm water here, and they are erupting to the surface as we speak and then spreading west along the equator. Now, the big news here is, bingo, 2 degree anomalies now showing on this chart in the far West Pacific, suggesting that the past, 4 or 6 weeks worth of westerly anomalies in the Kelvin wave generation have indeed pushed more warm water into a consolidated ball here in the far West Pacific, and they are in the process of making the 3-month journey off to the east. So if we're in, we'll say August, all of September, all of October, this will hit here and then take another month or two to erupt to the surface, move into the official El Nino monitoring region, the Nino 3.4 region. I think this is all the fuel we need to get El Nino going. So it looks like we are in good shape. Here's another version of that same data, but rather than using buoys, this uses satellite data to sort of map out and uses some fancy tricks, and we'll get into that in a second. But it shows the same warm pool, maybe a little bit bigger, maybe a little bit denser, maybe a little bit warmer here in the far West Pacific. But you see this, just a full-on river of, 1 to 2 degree anomalies stretching the whole way, the maritime continent here. In fact, it starts about 125 west. You can see the water literally blowing from the westerly anomalies that were driven by the MJ, blowing through the islands of the maritime continent, falling into the equator region of the far west Pacific and then streaming the whole way across. Okay, and you also see pockets of 1, 2, 3, 4, 1, 2, 3, 4, 2 to 3 degree anomalies here. My guess is by the time this all gets together and winds up here, it starts warming as it gets squeezed up higher, and you'll end up with 4 degree anomalies out of this. And that's plenty of fuel for a building El Nino. Now, the one thing, this little cool pocket right here, and you see it right here, it showed up, it's been a couple of weeks, a month now, and it's only 1 degree below normal, but this is probably the beginnings of the end of El Nino getting poised to maybe do its thing. Maybe. A little bit early to know. We don't think anything's going to happen meaningful here for a couple of months at least, and even if it does, it'll take 4 or 5 months after that to have, you know, to erupt at the surface, and then even months after that before the atmosphere responds to it. So just something to keep your eyes on. Doesn't mean that anything imminent is about to happen. Sea level anomalies, this is the raw data used to build that last image. This is satellite-based data. It's just a satellite polar orbit around the planet, maps every square inch of the ocean surface over a period of, I think it's about a week to 10 days. And then you can strip out the wave heights, the wind waves, the tides, and is the sphere of the ocean higher or lower than normal? Why does that matter? Well, if you have cold water at depth, cold water tends to contract. That'll create a divot on the ocean surface, and it'll show up as negative anomalies. But again, what we only care about, 5 degrees north and south of the equator, right on the equator. That's the pipeline for Kelvin waves to move east. If you have warm water at depth, it expands, creates a bump on the ocean surface. Oh, and so Chile, Peru, Galapagos, Central America, equator there, dateline there, New Guinea there, you get the idea. Lots of 5 to 10 centimeter above normal anomalies, meaning lots of warm water off of Ecuador. But the pipe, the whole way from the maritime continent here, streaming off, full of warm water, and here's that developing pocket of 2 degree anomalies that we saw in the other chart from the buoys. This also is sensing that too, suggesting another Kelvin wave is in flight. Hooray! We're in a good shape. Upper ocean heat anomalies, the same sort of thing, but it gives it in a time perspective. West Pacific here, East Pacific here, the blues cold water, the reds warmer than normal waters. This is last year in August, the La Nina pattern. First Kelvin wave in November made it across the reds warm water, pushing across another Kelvin wave in January, another Kelvin wave in March, another one in April, the big one in May. We thought we were all done. We were worried it's all over. Notice the temperatures. They cooled, not quite as hot, but here we go. Here is our next Kelvin wave starting to build. Now, we don't think it's some massive Kelvin wave. It's more like a reinforcing final push of warm water off to the east. Maybe that'll help extend El Nino deep into next winter and into maybe even the spring beyond that. That is good news. Sea surface temperature anomalies for the Pacific Basin. Chile, Peru, Ecuador, Central America. Clearly see warm temperatures. This actually looks better than it did a week ago or 2 weeks ago, suggesting the east winds here in this area are starting to subside. And remember, there's westerly anomalies forecast for this area. So if anything, this in the next couple of weeks should start to light up even more. These are still very warm temperatures. They extend out to 130 west. And then you still have warm temperatures beyond that, but the warmest temperatures are here. So the eruption is occurring here. Easterly anomalies taking that warm water, pushing it off to the east. Okay, the warm water, I think last week we had actually warm water off of Southern California and Baja, but that was mainly an effect of calmer winds near shore and the ocean heating the ocean surface. Now we have a little resurgence this past week in the northwest winds, but we know that's all supposed to fade out. And any northwest winds a week from now are supposed to be from Cape Mendocino northward. The cool pool, the residual La Nina, high pressure, the high pressure bias we saw that's supposed to be gone on October 18th, that is still what's driving some of this here. But notice this big ball of warmer than the normal temperature starting to build off of California. That's a result of just heating. This is not El Nino directly related, but atmospherically, it could be a sign that, yes, high pressure is losing some of its grip. Yeah, maybe some of its seasonal change, but overall, I mean, you start looking out here and you see there's a lot of warm water here. Most of this is the result of high pressure being centered over this area, and it was nuking down here, but even this area where it was strongest appears to be fading and warm waters are building. I think it's only a matter of time till all this just collapses and it starts warming too. And when that happens, I suspect all this is going to start getting cooking hot really quick. Sea surface temperature trend over the past 7 days, pretty much a neutral pattern. You see a little, it's right on the equator. That's the only part we're interested in. Oh, and Ecuador there, Peru. You see a little bit of warming right here, suggesting that easterly anomaly pattern that was off of Ecuador is starting to fade, and we expect to see this, if anything, building over the coming weeks. And this, whatever light cooling that was here, this is the last lingering effects of those easterly anomalies. That'll all fade out too. See a building warm water pattern out here to the dateline. We're not going to say anything about it other than we think maybe that's where the Walker circulation is starting to take root. That's where the cloud cover anomalies are showing up, and we suggest that, or thinking that this is the beginning, another sign of the building Walker circulation. The backed off view showing the clear El Nino pattern, this triangle of warm water right here, classic El Nino, warming right in the center, very eastward displaced, which suggests the foundations of this El Nino are strong. They have been this way. This pattern has been in place for quite a while now. I don't know, since June, something like that, since the first Kelvin wave started erupting, all very eastward displaced. Again, sort of hints that the fundamentals for a strong El Nino are in place. All right, sea surface temperature index for the Nino 1.2 region. This is the area right up there along Ecuador and Peru. It's not like an El Nino, the true El Nino indicator, but it's sort of like the birthing ground for El Nino. Temperatures, well, neutral. A normal year is here. We were back at above 2 degrees above normal back in May. Today, we're at 3.075 degrees above normal, cooking warm. That just reflects what we saw in the previous image. Very warm water off of Ecuador. But the even better news is in the official El Nino monitoring region, the Nino 3.4 region. This is the area on the equator, 5 degrees north and south of the equator, from a point south of California out to almost the dateline. The first reading above 1 degree, just barely. 1.050, so 1 in 50,000ths of a degree above normal. But this is what the models have said we were heading towards. It is materializing, and we expect it to continue to build from here. The El Nino neutral is at 0. If you're half a degree above normal, that's considered weak El Nino. When you're at 1 degree to 1.5 degree, that's medium El Nino. So we barely have one data point, our toe in the door of saying medium El Nino, but when we look at the forecast, you'll see where all that goes from here. So how's all this compare to previous El Ninos and even with our existing El Ninos? So a week ago, July 29th, here's the warm water pattern off of Ecuador. Now here's where it is today. So it's gotten denser and building some. We think that's mainly a sign of east anomalies fading in that area. All right, so how does that compare to the 2015 El Nino at this time of year, August 6th? Well, there's really no comparison. We're blowing the doors off of that one, so that's a good sign. So how do we compare to the super El Nino of all super El Ninos, the 97 El Nino? Well, there is no comparison. Look at the density of the heat in that area. The extent goes out to 155. This one goes to 135. So there's really no comparison. But that was an extreme super El Nino. This, we don't know where this is going. We'll look at the forecast in a bit. But still, this is looking better than pretty much any other El Nino other than the 97 El Nino. We don't have hard data for the 82, 83 El Nino, but anecdotally, this looks better at this time of year. All right, what's the effect on the atmosphere of all this warm water and these clouds and outgoing long wave radiation? Is there evidence that what's happening in the ocean is actually taking hold in the atmosphere? And I'm happy to report, yes, there is. We're looking at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti over the Pacific, Darwin over the sort of maritime continent, Indian Ocean sort of thing. But when pressure is lower at Tahiti, the index goes negative. Hey, today, minus 27.07. Yesterday, minus 24, 21. Well, hey, we've kind of been negative. We had 2 days of positive readings, and I think that was right in the middle of the last video we posted, and it was like, oh, this isn't looking good. But prior to that, well, you go down this chart, and almost for the last 30 days, actually it's been the past 25 days, save 2 days, we've been negative. This is a really good sign. This again speaks to the fact that if the Walker circulation were setting up and the active phase of the MJO were in place, that we'd have a negative SOI, and we do. The 30-day average, well, we're at minus 10.18. Where were we a month ago? Positive. Positive. The 30-day SOI has gone negative to minus 10. This is a good sign, suggesting it's not just a little blip, but we're starting to get some traction. The 90-day SOI, minus 8.81. Where were we? We are, I don't even want to say it, but we're the lowest we've been in years. This is all sign that El Nino, we think, is getting traction. Here's the 30-day moving SOI all graphed out. Okay, the 0 is right here. That's neutral. When you're up in this area, that's La Nina, or the inactive phase of the MJ. When you're down here, El Nino. So you see the past in 2021, 2022, upward spikes, the inactive phase of the MJO dominating the downward spikes, which are the active phase of the MJO. And then as we got into, where are we, January this year, active phase, active phase, active phase. We had a little bump there in July that nearly gave us a heart attack, but now we're again on the trend downward. We know there is an inactive phase coming. It'll last for a week maybe, and then theoretically we're off to the races. One last little bit of information. The jet stream for the North Pacific. You're saying, wait, it's summer. It's the 1st of August. Normally about the 15th of August, I start looking to see what's going on in the jet stream, even about, honestly, middle of July. Today, we have a consolidated jet stream pushing across the North Pacific. Not strong, but not super north, and it's not split at all. And it's right now centering on the 50 north latitude line. Let's put this into motion over the next week. And what do we have? We have a trough starting to build on Friday. We saw this on the other wind model when we were looking at local winds for Hawaii and California. And falling down to about 47 south. And that, for this time of year, looks pretty reasonable. We're going out to Sunday, and I'm waiting for this thing to split, and instead it just keeps getting stronger and stronger. And then we get a big trough supposedly building, not big, but for the time of year, building in the West Pacific, right where the center of the Walker circulation is. And I go, this is interesting. I haven't seen this for quite a long time. This is a good sign. And then we go look at the wave model for the North Pacific. And we're not even looking at the hurricanes, and there's all this stuff going on over here. Now, if I saw something starting to recurve and go like that, I'd get very interested. But instead, what we get is, theoretically, and it's 102 hours out, a low-pressure system building in the northern Gulf of Alaska with, what? 2022, 24-foot seas aimed at the Pacific Northwest down into California? No way. And it probably isn't anyway. But you know what? I'll take it. It's, oh, and what? 28-foot seas is, the updated run of the model. So not so bad. Now, if I really want to see these guys recurving, but notice this. See this band of, it's not even like rideable surf, but it suggests a stream of, perhaps swell production building along here and pushing further south from 45 to 40 degrees north. This is all very good news, very unexpected, and it sort of makes one think, maybe I don't even need the southern hemi anymore. Maybe if I hold on for another week and a half, it's going to be a wash and we'll be into our fall season. Now that is a bold statement. I'm not saying it's going to be true, but I had the thought. So let's go down that rabbit hole. What's going on and what has changed in the past weeks? New developments. Building cloud pattern, that negative OLR, outgoing long wave radiation. It's evidenced near the dateline. It has been there since June 24th. It's possibly indicating the upflow of the Walker circulation developing there. Maybe. The North Pacific jet stream is consolidating and building. Yeah, okay, it's the GFS model. It's a week out. But it's a tease. You can't argue with the SOI is steadily dropping. And I think it's going to keep doing that. West wind anomalies have been holding over the Kelvin wave generation area since 7:15. That's not a forecast. That's hard reality. The SOI is hard reality. The outgoing long wave radiation is a hard reality. They are not a projection by a model. They're not some made up. It's not some, dreamed up a conspiracy theory about something going to happen. These are things that are happening right now. Evidence-based science. And we continue. A new Kelvin wave, weak as it may be, is developing in the West Pacific. And then we're off into voodoo land. The models all suggesting more of the same moving forward, and if anything, are upgrading some. And we didn't show you the actual model, the output from the CFS, but we'll do that in just a second. And so that brings us to the CFS version 2 forecast, sea surface temperatures for the Nino 3.4 region. All right, today, where are we? We're somewhere in late July. Temperatures 1.15 degree above normal. That's what the model says. We're there pretty much. Temperature as we get into September rising to 1.6 degrees above normal. By October, 2.05, building to 2.2 degrees as we get into November. That's super El Nino status. Now, this is the not corrected version of the model. The corrected version suggests temperatures holding about where they are now for about till August, and then we're off to the races, eventually reaching to 1.7, almost 1.75 degrees above normal. So this is strong El Nino status. The previous model was super El Nino status. Anywhere between the two, I'd be perfectly happy. All right, so given that bit of information, what are the unknowns, or what are the things we're debating in our mind? Is the Walker circulation building towards El Nino? I'd say the evidence tips what was a 50-50 to a 75% yes, 25% no. You might have different thoughts. Let me know your thoughts. Will west wind anomaly pattern continue over the Kelvin wave generation area? Seems pretty likely. I'm back from 50-50 to 70% yes, 30% no. Are more Kelvin waves in flight or expected? Just one more. That's all it takes. Is the ocean and the atmosphere coupled? Well, that was not in a good place. I'm saying I'm not completely sure, but I'm way better than the 50-50 I was last video. 65% in favor, 35% in not. Will the warm pool in the east discharge before coupling occurs? I'd say almost non-existent. I'll say 20% yes, 80% no. And then, of course, the big thing, is the model guidance believable? I went from, I think it was 45, 55, or 50-50 last week to 65%. I'm going with it now. 35%, I'm still holding in doubt. All right, things have turned, I believe, and for the better. It looks like we have a Kelvin wave in flight. It looks like we have good solid west anomalies in play, a little bit of a blip for a week, and then we're off to the races. And all the models suggesting the same thing. The interesting thing is the jet in the North Pacific and a potential for a gale. Again, I don't believe it, but that's exactly what I want to be looking for. And that then tells me if that's going to happen, then the Southern Hemi, again, this massively split jet stream, maybe it's just given up for the year and it's over and the whole focus is going to turn North Pacific. That seems hard to believe, but the pattern is so dug in down south that it seems maybe possible. So we'll keep our eyes on that. Over the short term, though, small New Zealand swell radiating north, going to hit Hawaii first. I think it was on Thursday, and then California on Saturday, at least the meat of it. Size, very minimal, nothing great. Wind swell continuing for North and Central California, but the north wind pattern looking like it might really collapse and not become too much of an issue, which then sets up warming off of California, and that feeds into the whole building El Nino pattern. And all other data suggesting a march in the right direction. I think we're over the hump. What do you think? Let me know. Otherwise, if you haven't subscribed, please subscribe. And if you want to make a donation, you can do that. I want to hear your thoughts, though. And other than that, we're going to do it again. Yeah, it won't be a whole week. It'll only be 6 days. We'll do it on Sunday. So stay tuned. Keep watching. It's great to see y'all. We'll do this again next week. Same time, same channel. See you then.